Dear students, today we start gastrulation in cheek. Yesterday we studied about the blastulation. The blastulation and gastrulations are the process after fertilization is over. It is just a division of the cell, that is zygote. Zygote is a single cell, but it is having the male gamete nucleus and female gamete nucleus. They get united and zygote is formed. It is single cell, and after fertilization they start division. So they divide, and up to the first stage, that division is called as cleavages. And after this cleavage process, you get one structure that is called as blastula. And the image you can see, this is the blastula. You see the clear cut, the front view, side view, and top view. The first one is the top view. You can see the anterior and posterior and section. So the division of the cells get continued. The next process is the gastrulation process is there. So in gastrulation, again the cell divide, and one point reaches where the actual embryo get their position. The small tissues of the future organs get developed in the gastrulation process. That we have to see the today. Before that, you can see this diagram. First of all, in the gastrulation process, two major things are there: the formation of endoderm and the formation of primitive streak and mesoderm. So actually, the three germ layers are there: ectoderm, endoderm, and mesoderm. In the blastula, the ectoderm is formed. Then in the gastrula, the endoderm is formed, and next primitive stick and the mesoderm. So what is this actually endoderm? The endoderm or hypoblast develops as a single layer of cells inside the primary blastocele. So actually what diagram you can see here inside this, suppose this section is there, in between these two, the primary blastocele is there. So inside this primary blastocele, one cell layer is appeared, and after the formation of endoderm, the upper layer is called epiblast or ectoderm. So when this yesterday I have shown you the diagram, the hypoblast or primary cells are there, and ultimately that become mesoderm, the upper one become the ectoderm. So the space lying between these forms are true blastocele, and cavity laying below hypoblast above the periblast is the archenteron cavity. So the blastocele is the original cavity. That cavity get divided by the formation of mesoderm. So you will get blastocele and another cavity that is called as archenteron cavity. It is just occur due to the division of the cell and arrangement of the layer. So in this way the endoderm is formed. So many theories are put forward how this endoderm is formed. That is infiltration theory, polyinvagination theory, delamination theory, theory of involution, and theory of invagination. Actually, what happened? The division of the cells get continued, and because of their numbers get increases, and they get rearranged inside the blastocele. They get entered into the blastocele. So naturally, we called it as infiltration or invagination or involution, whatever it may be. So as per the movement of the cells, the various theories get put forward. But we are interested in the formation of endoderm and the mesoderm. So the side cells in the area opaca, so side cell get entered and you will get the mesoderm. Later on we will see the diagrams. Then the formation of primitive streak and mesoderm. This is very important. So now I am showing some diagrams. From that, you see the first one. That is very interesting. You will get this diagram where the blastocell is already formed. So peripheral area is called as area opaca. Middle one is called as area pellucida, and anterior and posterior side. Now listen very carefully. So the second step in the gastrulation is the development of primitive streak. You can see here one thickened area of blastoderm below on the posterior side, and the subsequent formation of mesoderm. The primitive streak appears as a thickened area in the mid dorsal line at the posterior region of area pellucida. See the diagram. Area pellucida, middle one. On the posterior side, you will get thickened area of blastoderm. That is the cells, blastola cells, that is called as blastoderm. Then what happened? The inner lining region pellucida at the about 8 hours after incubation. So when this gamete is zygote is formed and the incubation starts, so after 8 hours you will get this structure. Then the thickening is due to the convergence of the cells of the blastoderm towards the center. Convergence means movement. So just I've told you, there is a movement of the cells are occur, and due to the movement, the various types of cells, organs, and ultimately after 21 days, you will get the offspring. So in the early stage, the primitive streak is broad and short and is called as short primitive streak. See, this is grow, then here you will get another growth, and this is called as, and the posterior side, primitive streak taking in shape. So this is short primitive streak. So it gradually extends forwards and reaches the middle of the blastoderm. So you will get up to the middle. Then what happened? The primitive streak is well developed at about 18 to 19 hours. So how many time takes place? 18 to 19 hours of incubation. This mature primitive streak is called definitive primitive streak. Definitive. See here in the D diagram, it grows. And the development of the primitive streak is influenced by the underlying hypoblast. So from the lower side, or the posterior side, the cells are get added, and the primitive streak is get growth is there. Now the next one, that is the, you will get the complete developed of primitive streak. So along the middle of the primitive streak, the runs narrow furrow called primitive groove. See in the middle. So whatever the cellular structures are formed elongated, you will get the groove in the middle. The edges of the groove are thick and are named a primitive fold. So side one. At the anterior end of primitive groove, there is a mass of closely packed cells called Hensen's node. See the diagram. At the anterior side, you will get the cells called as Hensen's node or primitive knot. The center Hensen's node are funnel-shaped depression called primitive pit. So actually this is microscopic structure, and the primitive pit represents the vestige of neurocentric canal, and posterior the primitive streak is resting on a plate-like structure called primitive plate on the posterior side. After that, so it is taken place in the 18 hours of incubation. So the 18 hours, the part of area pellucida adjacent to the primitive streak is beginning to show increased thickness. So now after 18 hours, the area surrounding this primitive streak get thickened, and this is called as embryonal area or embryonic shield. See here, the area opaca and middle one is the area pellucida. Now this growth is there called as embryonic shield. As the primitive streak elongates, the area pellucida also elongates. As a result, when primitive stick is fully formed, the area pellucida becomes elliptical. See, it is become elliptical. Now, the primitive stick functions as a pathway through which organ forming cells migrate into the interior of the embryo. So, now we are towards the conclusion how these organs are get formed. So the cells from the primitive stick invaginate into the space between the epiblast and the hypoblast. So the rearrangement of the cells are taking place in the cavities of this blastula or archenteron, and the cells invaginate individually in this area. So the process named immigration. And immigrating cells move towards the hypoblast and then spread out sideways and forward. See, forward there is a growth are taking place and invagination is there. So it is immigration of the cells. The cells which immigrated develop into a precaudal plate, notochord and mesoderm. See, anterior border of mesoderm, ectoderm of the head. So the all the organs, that is head, eyes, from the mesoderm, the digestive system is there. So all these in the little structure get started at the uh, above the primitive stick in the area pellucida. See the diagram. You listen very carefully and see the diagram. You will get the idea how the chicken is developed. Now, the mesoderm cells will not migrate anterior to primitive stick, and this mesodermal area, free area, is called proamnion. This region is called a site for the development of the head. Now, the precaudal plate cells, notochordal cells, are proliferate from Hansen's node, and this precaudal plate spreads under the epiblast in front of the primitive stick, and it is followed by the notochordal cells. These cells arrange themselves to form a cylindrical rod called head process, anterior part, or notochordal process. So from notochord, in future the vertebral column is developed. See, now this process is going on, and as a cells destined to become notochord and mesoderm and migrate into the interior of the embryo, the maternal which forms the primitive stick becomes gradually exhausted. As a result, primitive stick begins to shrink at the anterior end, goes backward. Hansen's node is carried backwards as the primitive stick receded, means dissolve. And the presumptive notochordal cells contained in Hansen's node continue migrating downwards and forward, so that notochordal process is prolonged backward. By the end of gastrulation, the primitive stick is reduced. See the diagram. It become very little one, and this residue becomes partly incorporated into the tail bud and partly into the cloacal region of the embryo. So in this way, here at the last diagram you can see the head fold, foregut, somites, notochord, segmental plate, and this little primitive stick get reduced in, and it get accumulated or get into the head, tail bud, or the cloacal region of the future embryo. So in this way, this is the development of the organs, various organs, and this process is called as gastrulation in chick. So it is very easy, but you keep in mind the diagrams, and this is the notes. These are the notes you keep in mind. So this is gastrulation, and next time we will see the extra embryonic membrane of the cheek. So extra, this is the next. I am ready, but it is very long chapter, so that's why I am ending here, and next time we will see the extra embryonic membrane of the cheek. So it requires for the development. Thank you.